Assalamualaikum. My group will present our tool, Apache Log Analysis Tool. My name is Syaza Izzati binti SALIHIN, and my other two members are ALIFF AIMAN bin RAHSIDIN and IMRAN bin SHAHARUDIN. This project introduces a Python-based tool for analyzing Apache log files to support digital forensics. It uses pandas, regex, and datetime to detect abnormal logins, failed attempts, and suspicious patterns. Features include IP geolocation, bar chart visualizations, and PDF report generation. Designed with a simple Kinter GUI for both technical and non-technical users. Helps organizations detect threats faster and improve cybersecurity response. The problem statements are: manual log parsing is time-consuming and inefficient, especially with thousands of daily entries. Many organizations lack automated tools to detect patterns like failed logins, unusual access times, or non-attack signatures. Traditional log systems are not user-friendly and lack real-time alerts or GUI, making them hard for non-experts to use. These issues delay threat detection and increase the risk of undetected security breaches. Our two relevance are log parsing, extract structured data such as IP address, timestamp, status code, and request type from unstructured log entries. Behavior detection detects abnormal login behaviors like repeated failed login attempts or excessive 404 errors. Data visualization generates bar charts for top IPs and access URLs to aid in pattern recognition. GUI interface provides a simple interface that allows users to upload log files and view results easily, even with minimal technical expertise. Our objectives are to develop a Python-based tool that can automatically parse and analyze system and server log files. Second, to detect unusual login patterns, repeated failed login attempts, and non-attack signatures using regular expressions and data analysis. And lastly, to provide visual summaries and reports that support digital forensic investigations.
Assalamualaikum, my name is IMRAN. My part will be explaining about the tools and the limitation. In our project, we propose the three tools that we are using. First is Ghost Access, OSAC, and Logwatch. Well, for their tools, there's a limitation for each of the tools. Number one, let's go through one by one. Is Ghost Access. We have no scanning, behavior, and detection. For OSAC, it's very difficult to set up and configure, and for Logwatch, it's not attractive and lack detail visualized inside. To fill the gap of the tools, we try to propose a different kind of way. So we try to add detection suspicious behavior for Go Access, and also perform a GeoIP lookup if there's intruder. For OSAC, we try to make a very simple GeoIP detection solution. For Logwatch, we try to generate PDF report and also include the GeoIP with GeoIP API. For system design, let's go to the two workflow. If you can see here, from the start, user will launch the GUI by Kinter, and then we'll go to the user select log file. If the file provide, it will go through to the system, but if not, it will show a show error message. Let's say it's yes, it will read the log file line by line, then it will pass log entries using regex and convert it to passing data to data frame. And afterward, it will get to the top address and try to get the request URL. Afterward, it will detect suspicious IP and IP accessing many unique URL. And then it will to export the full log and suspicious IP and scan to the PDF. By performing GeoIP lookup, it able to find the GeoIP of the suspicious IP, and also will display all the report and show in the paragraph and graph. And afterward, we will go through the Python library that we're trying to implement in our project. We have 6 of the Python library. Number 1 is RE, number 2 is pandas, number 3 is matplotlib, number 3 is request, number 4 is request, number 5 will be fpdf. The last one, of course, we are using Kinter.
Let's move to demonstration part. So here is our coding. This is all Python library that we use. We start with the backend function. For read log file, this function open the user selected log file and read its content like one-liner. The result is written as a list of string where each string represents one line from the Apache log. Next is parse logs. This function processes each line from the log file using a regular expression pattern. It extracts key components from the Apache log entry, including IP address, user identity, timestamp, HTTP method, request URL, status code, and response size. For the toData frame, this function takes the list of dictionary from parse logs and convert it into a pandas data frame, allowing for easier sorting, grouping, and filtering in later analysis step. And then we move to analysis function, get, which is get top IP and get top URL. This function count the frequency of each IP address and request URL in dataset. They return the top 5 most frequent entries, which can be used to identify potential attacker or hotspot of activity on the server. Next is plot top IPS and plot top URL. This function visualizes the top IP and URL using bar chart. This helps user easily interpret the distribution of traffic or suspicious pattern in a graphical format. And then next is detect 404 IPS and detect scanning IPS. This function applies heuristic rule to detect abnormal behavior, which is IP with a high number of 404 error may be scanning for vulnerabilities. IP assessing many unique URL may be performing enumeration or problem attacks. Both functions return a filter list of IP that exceed predefined threshold. And then we move to GeoIP function, which is get GeoIP info. This function send a request to the ipapi.com GeoIP API with a suspicious IP address and receive location information such as country, city, region, and ISP. Next is save GeoIP to PDF, which is GeoResult. This function takes the geolocation result and format them into a readable PDF report. Each line in the PDF lists an IP address and its corresponding location or an error message if lookup failed. And then next is PDF export to PDF. This function export the entire parse log dataset into a structured PDF report. Each row in the log is converted into a string and returned to a multi-line cell in the PDF. And then save suspicious IP to PDF. This function takes a dictionary of IP which count and create a simple PDF file listing those IP and their hit count. And then we move to the main function, which is run analysis. This is the core function that connect the GUI with the backend processing. When the user click the run analysis button, this function is executed. It performs the following step, which is read the selected log, parse and structure the data, analyze IP and URL, detect suspicious pattern, perform GeoIP lookup for suspicious IP, display summarized result in the GUI, and then generate PDF report for all results and notify the user with a pop-up when complete. So I try and run the system. So this is our tool. You click browse and then select the file that you want to execute. For example, this one. You click open and run analysis. The tool will pop up two bar chart. First is top IP address, and then top request URL. And here you can see list of top IP address, top URL, suspicious 404 IP, and potential scanner. And you also can save in your folder output in PDF for geo IP, log report, scanning IP, and suspicious 404.
To demonstration, there's the key output of the system. If you see the first slide of the key output, you are able to see the key, the top IP address by SSH count. So we show the IP address and the number of the frequent. If you go to the second one, the second slide of our key output, we are able to see the URL that trying to breach our file. Last two is the PDF report of the IP address and number of frequent hits. And the last one is the suspicious IP address in PDF. And last one is geo IP report. You're able to see the geographic IP of the user. So like in here, we're able to see one of it was in United States, Virgin Islands. And also be able to see there's another US attack from US, and that's it for our key output. Thank you so much. My name is IMRAN.
While developing our tool, we encountered several challenges. First, the Apache log format varies depending on server configuration, which made it difficult to apply a single pattern. We addressed this by using flexible regular expressions that adapt to different formats. Second, we faced GeoIP API rate limits, especially when analyzing multiple IP at once. To solve this, we optimized the process to query only suspicious or repeated IP addresses, reducing IP usage. Lastly, converting dynamic data to structured PDF report was tricky. We overcame this by using the PDF library multi-cell function, allowing better layout and formatting of large variable data. The impact of our tool is meaningful for the field of digital forensic. It shows how a Python-based solution can automate Apache log analysis and help detect suspicious login, IP origin, and access behavior. Our simple GUI design makes the tool accessible not only to forensic professionals, but also to student and administrator. It bridges the gap between complex raw log files and readable, actionable forensic insight, laying a strong foundation for future upgrades like real-time monitoring and machine learning-based detection. Overall, it provides a practical and user-friendly solution that supports faster threat response and investigation. Looking ahead, we see multiple opportunities to enhance this tool. First, by adding real-time monitoring, we can enable live log tracking and instant threat alerts. We also plan to support multiple log formats, including Windows event logs, syslogs, and cloud-based resources. For smarter detection, we aim to integrate machine learning to catch more complex or previously unknown threats. Performance will be improved using multi-threading or streaming to handle large logs efficiently. We will also focus on usability by including tutorials, documentation, and clear error message. Finally, we plan to integrate our tool with CIEM platforms like ELK Stack, Splunk, and Autopsy, expanding its role in broader forensic ecosystem.